Okay, so we're doing the same thing. Well, at this point it's not the same thing because you haven't seen it, but I filmed the sulfuric acid one first, but I'm showing it second for dramatic effect. What we have here is a little piece of, I'm pretty sure it's 100% cotton, from an old shirt. I always wear these white Oxford shirts. So that's just water. Put that in there. And let me remember to put on my safety goggles. Okay, now, so that's 52 mils of water. And now what we need to do is add 48 mils of concentrated HCl. There-ish. 48 mils of that. Should have done that probably. 48 mils of that to get a 5 molar hydrochloric acid solution. So let's see what that does. Is it doing something? Not really. Yet. Well, it's definitely bleaching it. See how the color is changing? Color is definitely changing. So I think it's just, that means it's breaking down the dyes that are in it. So let's leave that for a while. I'll come back in about 10 minutes. So it's been about 10 minutes. And just hasn't done a whole lot. So I would like to take this from 5 molar up to 6.5 because I don't have a whole lot of HCl left. I have another whole bottle on the way. But maybe if we get it to 6.5, we can get something else going and see if it does anything more exciting beyond just slightly, partly changing color. I wonder if it doesn't seem that it's even like changed texture at all. You'll see that will become significant later when you watch the one on the, oh, it's gotten a little thinner. I can definitely tell it's gotten a little bit more diaphanous looking. All right, let me measure out some more HCl and I'll be right back. Okay, so what we have here is a little bit of that cotton in 100 mils of a 5 molar solution. To get this from 5 mol to 6.5 mol, we need to add another 39 mils of 32% concentration or 10.2 mol, whatever, HCl, which I'm going to do relatively quickly. The sulfuric acid, as you will see shortly, does react and heat up and begin to boil and everything because of the dissociation. It's actually a 2-step dissociation with H2SO4. But if we get a little bit of heat from that dissociation, it can sort of help along some of the reaction, and breaking down some of the heat might help break down some of the cellulose. So here's my 39 mils of hydrochloric acid, and we're gonna chunk it in to get a total of 139 mils of a 6.5 mol solution. So here's that. And generally speaking, HCl doesn't really get all that, doesn't get hot and angry in near the same way that sulfuric acid does. This is probably a little warm, but sulfuric acid gets like uncomfortably hot to the touch, you know, starting to boil hot. So let's leave that for another 10 minutes. And you can see already how see-through the cotton is. That's partly, I'm sure, because the dyes are breaking down and it's becoming, you know, clearer, natural colored, whatever, but I'm sure also it's partly the breakdown of the cellulose. Cellulose is a carbohydrate related to glucose, and the sulfuric acid loves to dehydrate, so it can break down that cellulose carbohydrate really well. And H2SO4, sulfuric acid, is also a strong oxidizer. HCl, hydrochloric acid, is not an oxidizer, so we don't have that element, figurative element, we don't have that aspect of the reaction going on here. This is warm, it's barely warm to the touch, even through these gloves. It's not getting warmer. So we'll leave that for a little while. I'm gonna go have dinner. So, call me impatient, but I think that's just doing as much as it's going to do. It's not terribly exciting, but what is exciting will be neutralizing it. That's what we get out of that, I suppose. Again, the oxidative effects of the sulfuric acid aren't present here. And yeah, so that's interesting. I looked into putting some hydrogen peroxide in this, but at these concentrations of the hydrogen peroxide and at this molarity of hydrochloric acid, one of the things that is released is chlorine gas, and I'm not up for that. I don't have sodium thiosulfate or a scrubber or a fume hood, so just no need for that. So just cause, let's go ahead and, shall we? How very different from the sulfuric acid that you're about to see.